Okay, let's look at homework 5, problem number 5 example. All right, so I'll do a similar problem. So it says that we need to prove that arc hyperbolic cosine of z is equal to natural log of z plus or minus square root of z squared minus 1. All right, so let's do that. Alright, so first we're gonna let let's see, w is equal to so we're gonna let w equals arc hyperbolic cosine of z. Right, so we're looking for w. Right. Alright, then since I don't like arc hyperbolic cosine, so I'm going to rewrite it in terms of hyperbolic cosine. So this is going to be a hyperbolic cosine of w, so it's going backward, so w goes to z. Alright, by definition, hyperbolic cosine of w is e to the w plus e to the negative w over 2. So which is equal to z. Alright, then I'm going to just go ahead and multiply by 2. So you can see that you can cancel 2 and multiply the right hand side by 2. So you can do that, right? Right. So maybe I should say multiply by 2. Right. Then next step would be we're going to use a substitution. Let u be e to the w. Right. So the equation becomes so you have a u here plus e to the negative w is e to the negative 1. U to the negative 1, which is equal to 2z. Right? I don't like having a negative power, so I'm going to multiply through by u. That way you will have u squared plus 1 is equal to 2zu. Right? Then since this is a quadratic equation, so I'm going to put all the terms on the left by subtracting 2zu. So you will get u squared minus 2zu plus 1 is going to be equal to 0. Right? So we can use a quadratic formula to find u. Right? So u is going to be equal to negative b. So negative, so it's going to be 2z plus or minus square root of negative 2z squared would be 4z squared minus 4, a is 1, c is 1, so it's going to be just that, over 2 times a is 1, so that's just that. Alright, we can pull out 4 from inside the square root, so that becomes 2 outside. So you have a 2z plus or minus 2 times square root of z squared minus 1 all over 2. Right? So you can see that you can cancel 2's on top here and the 2 on the bottom, and then you end up getting, right? And also u is a substitution for e to the w, so I'm going to go ahead and put that e to the w here. And here all the 2's are gone, so what's left is z plus or minus square root of z squared minus 1. Right? Then since we're looking for w, so we have to isolate w, but we can take the natural log of both sides. Then you get w, which is equal to natural log of z plus or minus square root of z squared minus 1. Right? Which is exactly what we're looking for. Right? So that's the arc hyperbolic cosine of z is equal to natural log of z plus or minus square root of z squared minus 1. Right? That's it. I hope that this was clear.